Hello, everybody. Here's a question I came across today, and I had some of this information kind of buried in another video that I've already posted, but I thought it'd be nice to just highlight this topic right here in a video all by itself. Okay? And the question is, how to simplify expressions with roots, and roots might more properly be called radicals, but as far as I'm concerned, you can call them what you want. Okay? So let me walk you through this. So first, say we had something like square root of 25. Square root of 25 is no big deal because 25 is a perfect square. Square root of 25 is 5 because 5 squared is 25. Okay, so no controversy with that sort of thing. But when we get something like square root of 50, and say 50 is not a perfect square, like, it's square root of 50 is probably about 7, but I don't know. It's not a nice round number, so there's nothing I can do with it on its own. But in math, we like to reduce things down to their lowest terms in general. So how do we reduce root 50 given that it doesn't calculate into a nice round number? Okay, here's what we do. We take 50 and we find the largest perfect square factor of it. Okay, so here are my perfect squares: 4, 9, 16, 25, 36, 49, 64, 81. They keep going. We probably won't have to look past that though. But we find the biggest number on this list that factors out of 50, that'd be 25. Okay, so my train of thought is, okay, 50 is 25 times 2, and then radicals have this property where you can split them apart. The square root of 25 times 2 is the square root of 25 separately times 2. Okay, do we know the square root of 25? Yeah, the square root of 25, that's a perfect square, nice round number. It's 5, so it reduces to 5 root 2, and that's as small as we reduce it. Let's look at another example. Suppose you had 72. 72 is not a perfect square either, but I would look for the biggest number on this list that factors out of 72, and that happens to be 36. So 72 is in fact 36 times 2, and because roots and radicals split up across multiplication, then this is individually root 36 times root 2, and root 36 is 6, so it's 6 root 2. Okay, so root 72 reduces to 6 root 2. So that's part one. It's just how do you simplify roots when you're dealing with perfect squares versus not perfect squares. Okay. Second part is this is kind of the residue of the quadratic formula, and I want to talk about how we would reduce that. Okay, because at this stage in our class, you'll be encountering the quadratic formula, a fair amount. So say you had whatever you're doing, you end up here, 6 plus or minus root 40 over 2. So there's a few stages of this problem. First stage is root 40. Now I'm thinking of that like, is it root 25? Is it like root 50? Like what? Okay, 40 is not a perfect square, but 40 is 4 times 10, and you know what happens from here. It's going to be individually root 4 times root 10, and root 4 is 2, so it's going to be 2 root 10. Okay, so there's my first step. Now I would like to cancel some numbers that I can. I mean, in math, that's, if we can get rid of a number, we'd like to do it in general. And so many people, they're going to be tempted to cross out the 2's. You see you got a 2 over a 2, but that's not how it works. Think about what canceling is. We cancel addition with subtraction, and we cancel multiplication with division because they're opposites. Addition and subtraction are opposites, and multiplication and division are opposites. Here I'm adding and subtracting the 2. That's not the opposite of dividing by 2. So these 2's wouldn't cancel. Okay? Because they're not opposite. I'm not canceling multiplication with division. This is adding. I don't cancel things with dividing that are added and subtraction just because those are not opposite things. Okay? You might think of it kind of like this. If I had 5 and I multiplied by 2, but what if I then divided by 2? Wouldn't I end up back at 5? Like, it'd be completely unnecessary to take 5, multiply by 2, and then divide by 2. You'd be going in circles. because the opposite of multiplying by 2 is dividing by 2. That's what canceling is. So here's what we do. We factor, okay? So look at the 6 and the 2 there and see if you can factor out a common factor. And in fact, 6 and 2 have a common factor of 2. So I factor a 2 out, and I can even double check. What if I remultiply? What's 2 times 3? That's 6. And what's 2 times root 10? That's 2 root 10. And then now look what I'm looking at. I've got dividing by 2 and I've got multiplying by 2. So what did we say? Multiplying and dividing, those are opposites. Multiplying by 2 right here, dividing by 2 right there, those cancel. Alright, so then those 2's are gone and I get 3 plus or minus root 10, and then I'm done at that point. Okay, so that's how I'm going to recommend going about this. There are slightly different ways you could think about it. You get real good at math, you end up not having to think about stuff like this at all. But if you want some steps, if you want to delineate the process and have something to go back to that's reliable and the same every time, this is how you would reduce such an expression.